Resistor. Resistance is the property of a substance due to which it opposes the flow of current through it. Resistance equal to rho L by A, where rho is the resistivity of the material, L is equal to the length of the material, A cross sectional area of the material. Resistance is a temperature dependent quantity. R equal to R naught 1 plus alpha T minus T naught, where R is equal to the resistance of the temperature, where R is equal to resistance at temperature T. T naught is equal to 0 Kelvin. R naught is the resistance at 0 Kelvin. Alpha is the temperature specific coefficient. The electrical resistance of a circuit component or a device is defined as the ratio of the voltage applied to the electric current which flows through it. R equal to V by I. In an open circuit, no current flows through it. In a short circuit, the voltage is zero. So in an open circuit, resistance is infinite, and in short circuit, resistance is zero. Inductor. The circuit element that stores energy in the form of a magnetic field is an inductor. Inductor does not allow sudden change in current. The current flowing through an inductor is given by 1 by L integral over minus infinity to t v dt, where V is the voltage across the inductor. The voltage across the inductor is given by L di by dt, where I is the current flowing through the inductor. The self-inductance of a coil is N phi by I, or N square mu A by L, where N is equal to number of turns in the coil, mu equal to the permeability of the material, A is equal to the cross-sectional area of the coil, and L is the length of the coil. Energy stored in an inductor is given by Li square by 2, where I is the current flowing through the inductor. An ideal inductor does not dissipate energy. Power loss in an ideal inductor is zero. Capacitor. The circuit element that stores energy in the form of electric field is called a capacitor. Capacitor opposes the sudden change in voltage. Capacitance is given by C equal to epsilon A by D, where epsilon is the permittivity of the material, A is the cross-sectional area of the metal forming the parallel plates, and D is the distance between the two plates. Also, C equal to Q by V, where Q is the charge stored and V is the voltage. Capacitor current is given as C dV by dt, where V is the voltage across the capacitor. Voltage across the capacitor is 1 by C integral over minus infinity to t I dt, where I is the capacitor current. Energy stored in a capacitor is equal to CV square by 2. Like an ideal inductor, an ideal capacitor does not dissipate energy. Ideal voltage source. There is no internal resistance present in an ideal voltage source. So the entire voltage is present at terminals A and B. Practical voltage source. Some internal resistance is present in the source. So entire applied voltage is not present at terminals A and B. There is some voltage drop internally. Ideal current source. Internal resistance of an ideal current source is an infinite. Practical current source. The internal resistance of a practical current source is not infinite. Star and delta networks. Star conversion. Delta conversion. Star to delta conversion formulas. Delta to star conversion formulas. The above formulas are same for resistance and inductor networks. But for capacitor network, replace every term by 1 by C. If value of each resistance is R in a star network, then the corresponding value of resistance in delta network will be 3R. If you liked this video, please do like, share and subscribe to my channel. Thank you.